नहीं मैडम Good evening, dear students. Arjun, good evening. Sri Kumar, good evening, good evening, good evening. Come on, join the session. Yes, yes, dear students. Very, very welcome. Rahul, good evening, good evening. So, welcome to the Gradeup, the India's largest e-learning platform. Come on, join the session. Shivani, very good evening, dear. Yes, yes. Welcome, welcome to the Gradeup. Sunita, very good evening. Very, very good evening. Yes, come on, join the session very fast. Join the session very fast, dear students. So this is the series. Deepak, Mohite, Namaskar, good morning, good evening. Shobna Devi, good evening. Satish, good evening. Nice, nice to see you all. Nice to see you all. Okay, Krishnamurti. Definitely we are going to start. Definitely. Let the people come. Let the crowd come. Please share this amongst your friends. Invite them to join. Okay. Share this session. Like this session and ask your friends to join the session very fast. Kuldeep, good evening. Good evening, good evening, good evening. So this is the fourth session, dear students, that we have. This is the fourth session, right? The Vizag Management Training 2020. Okay, for that we have planned the 550 plus practice questions. This is the series. And okay, what was the question, dear? Tell me. I hope you answered it yesterday only. And please, if you look at the comment box, yesterday's question. So the question on the segregation, okay, in the question regarding to the poor machinability. So I explained you the phenomenon of segregation, but the result of this segregation, which is result into the dense structure, that is correct. That is correct. Okay, I hope if Ramim San is there or any other is there, so I was firm with my point. It is okay that phenomena is segregation, but the resultant structure, because the properties we can directly correlate with the not the phenomena, with the structure of the material, and the structure which results is the dense structure. Okay, and that is the reason why we could not able to have the very good machinability on that, and that is the reason. So Rahul, tell me what is the answer yesterday's question. Okay, fine. So I hope this is the okay thing. This is the okay thing for you. So yesterday there was a question related to the machinability, poor machinability because of the centrifugally casted pipe made up of cast iron, and I explained you the phenomenon of segregation, but that phenomenon of segregation results into the dense crystal structure, and that is the answer actually. Okay, yes, yes, actually Rahul, that is the correct answer. If you are saying it, yes, absolutely correct. Okay, fine. So see, dear students, this is about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. So till now I have mentored more than 10,000 number of students. My area of expertise are production engineering, the mechatronics and robotics, the fluid mechanics and industrial engineering as well. And today's session we are going to have the leftover topic. So क्या क्या बचा था अपना? So related to the material science, welding technology, and some of the part from the metrology that we'll try to cover. Okay, if any additional session if you get, definitely we'll try to cover remaining part also. So let us begin. Bhaiya chalu kar do. So please, are you with me? And the chat box should be continuously moving with your responses. Okay, let's start. Let's begin. This is the first question of the eve. Sunday eve. Chalo batao beta. What the question is, which of the following welding processes uses non-consumable electrode? So yes, I want your answer in the chat box. Come on. Come on, very good. Yes, of course. The first question, this is going for the 6, and congratulations to all. We have won the match, right? Very nice. So dear students, when you talk about the tungsten inert gas welding or the gas tungsten GTAW, gas tungsten arc welding, definitely in that we are using the non-consumable electrode which is made up of the tungsten, Okay, yes, it is not melting. Tungsten is having huge melting point, that you know very well. Okay, and sometimes to increase its melting capacity or melting point also, or current carrying capacity also, we are using we are adding sometimes zircon or thorium into that. So the electrode now called it as the zirconiated or thoriated tungsten electrode, that you know very well. Very good. So the TIG welding is the correct answer. Yes, instead of you go for the MIG. So dear student, this is the metal inert gas welding. Definitely there we are using the consumable electrode, right? That is, electrode wire is there which is consuming, and that is the reason why we can go more than the 5 mm thickness very easily. TIG, definitely the very important limitation, we can say, rather, we can weld the plate thickness lesser than 5 mm, because if you go more than that, definitely you have to use the filler material, and whenever there is a filler material into the arc, there are chances to have the contamination of the weld. So TIG is very suitable for TIG and MIG. Both are the actually made for joining of the very highly reactive materials like we have aluminium, magnesium, and again it is also used for the joining of the stainless steel also, right? Yes. So this is somewhat background about the TIG and MIG. Okay, go for the next question. And one more important limitation or disadvantage when we are using the filler rod in the TIG is that, okay, the contamination, definitely there are chances to happen the contamination, because the dust particle or impurity can reach into the weld pool through the filler rod. And second very important limitation is that even though tungsten is not going to melt, tungsten electrode not going to melt, but what happen at higher temperatures, there can be diffusion of the tungsten atom from the tip of the electrode into the weld pool, which can make the weld pool brittle. So this is very important limitation of the TIG. Please remember this. Okay, Sarthi, good evening. Come on, join the session and have the interaction with me in the chat box. I welcome all of you on behalf of the Gradeup. Okay, so please share this session, like this session, and do follow me on the Gradeup app, dear students. Do follow me on the Gradeup app. Yes, this is the next question in front of you, dear students. Come on, answer this question. So definitely just at the time of passing the current, it is not done here. Okay, it is not done just only the passing the current. No, after passing the current, there is a melting of this material. Okay, formation of the spot, and of course after current passing, the material is going to get melt. Then till we are having the load there from the electrode. Okay, so when we are just release the load or release the pressure, so just passing through the current, there is of course the pressure is applied. Okay, during the heating period is also pressure is applied. So after completion, not only after completion of the current, when the weld spot is getting cooled, then only we release the pressure. Please remember, C is very correct answer. Please remember this. So during the passing of current, there is a contact of the electrodes onto the plate. We are applying the pressure. During the melting of that spot, melting of that nugget, yes, it is there, pressure is there. When it is getting solidified, until it gets solidified, until it is get cooled, we are applying the pressure. So for ISRO interview, dear students, see that there is only one thing is that the throughout study of the subjects, okay, with the standard reference books, okay, you have to in the complete derivation part of everything. Okay, for every question they are asking for the derivation, so that is the main thing. So you should be able to prove each and everything with the help of derivations, right? So for every answer you should have the proof. Okay, that's how you can prepare. There is the only way. Yes, ठंडा होने के बाद. That is correct, boiler Rahul. Boina Rahul. That is correct. That is correct. Take the next question. Take the next question. Take the next question. Sarthi, I hope it is okay. You should go through the standard reference books for each and every subject, whatever your area of interest that you will tell at the time of interview. For that, you should know each and everything in the form of the derivations. That is first need if it is satisfied, then your interview will go in the correct direction. The material used for the coating the electrode. Yes, whichever the material we are coating, there are the two types of electrodes that we are generally using in the electric arc welding. Okay, so why we use this fluxes? That flux is the correct. Of course, Delhi is the correct answer. Delhi is the correct answer. Yes, Ganesh, Arjun, Shivani, Kuldeep, खड़से साहिब मुक्ताई नगर का, कृष्णा, कल्पेश. ओके, सो विकल्प डी है, बहुत ही बढ़िया विकल्प है. दैट इज करेक्ट. फ्लक्स इज करेक्ट. ओके, सो देयर आर the various purposes that can be satisfied when we are coating the electrode. We can able to supply the flux. We can able to have the safeguarding of the weld pool from the contamination from the say atmosphere. Again, we can able to supply some alloying element through that flux. So these are certain advantage that we can get when we apply the coating on the electrode. That is correct. D is correct. D is correct. Neha is correct. Very good, very good. Right, come on, join the session. Of course, flux is the correct answer. Flux is the correct answer. Yes, Kalpesh Ingre, बरोबर है. Next question. In arc welding, arc is created between the two electrode and work by okay, fine, no issues. Yes, to stabilize that. That is again very good, Shivani. Very good. Excellent, 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 Shivani. Yes, yes, Ganesh. Okay. So tell me what is the answer? In arc welding, we are talking about in arc welding. Dear student, in arc welding, not in a resistance welding. How the arc is created? By the moving of the electrode. By the moving of the electrode from say cathode to anode, anode to cathode, the flow of current. The arc welding arc is generated or created between the electrode and work by. It is simple theory that we have. There of the flow of the ions as well as the negatively charged current, that is from cathode to anode and cathode to anode to cathode, that like we are having, that is nothing but, dear student, what it is? Because of the flow of current. The arc is created because of what? The arc is created because of what? Yes, that is correct. Flow of current. Flow of current. That is very excellent question. Flow of current. That is correct. That is correct here. That is absolutely correct. Okay, that is correct. Flow of current. Flow of current. This is correct. Yes, yes, polarities, that is very important. We are having direct current straight polarity, we are direct current electrode negative, or we are having direct current reverse polarity, that is direct current electrode positive. Okay, so yes, that is, we are having two polarities, straight polarity and reverse polarity. So here the electrode is negative, and here electrode positive. That you know very well. So definitely in the electrode negative, if there, then we will get the maximum heat at the work, that is at the anode. Then we will get the we can able to have welding of very thick plates. We can able to weld the materials with the higher melting temperatures. So that these are the advantages we get through the straight polarity. In the reverse polarity, there will be the maximum current or maximum melting point at the electrode side. Okay, so in that case, the minimum thickness plate or the melting point of the plate is minimum. We can able to have the reverse polarity. Okay, no, it's a flow of current only. Flow of current, that is excellent. That is correct answer. So welding process using the pool of molten metal. Next question, answer this question. The pool of molten material. The pool of molten material. So main thing is current here. Yes, Ganesh correct, Giriraj Singh it is correct, Sunita correct, Shivani correct, Arjun correct, all are correct, all are correct. Yes, excellent. So dear students, yes, Kuldeep correct, Kalpesh Ingre बरोबर है बाबा, बरोबर है. Yes, correct. Sai Venkata very correct. Shobna Devi correct. Neha Arora correct. Excellent. Saw, it is a saw. Yes, in submerged arc welding we cannot able to see the arc. The arc is completely submerged. Okay, the completely submerged into the weld pool, and it is having the coating of the coating of the granulated flux. Okay, granulated flux which is there in huge amount, and the arc Yes, Boina Rahul, that is correct. So there is a huge molten metal is there. Yes, that is the pool of molten metal we can observe in case of the submerged arc welding. Okay, so the thickness of the plate up to 75 mm, that can be very easily welded in a single pass. That is a specialty of submerged arc welding, huge thickness of the plate. And even if you go for the electro slag welding, then again you can go more than 75 mm thickness of the plate in a single pass. Yes, thick plates can be joined by this submerged arc welding. That is excellent dear student. I hope all are you well prepared. Very good, very nice preparation is going on in a very proper and correct way, I can say like that. Very good. Take the next question. Filler metal or material. So I hope, yes Sunita, that is absolutely correct. In shipbuilding, filler metals are used in electro slag welding. This is again, you cannot categorize into the arc welding or not any other. It is kind of special kind of welding technique where the huge thickness of plates are getting welded by using the resistance of this molten metal slag, and that is creating the heating effect. That is electro slag welding actually. Okay, electro slag welding. Yes, that is absolutely correct dear students. That is absolutely correct. Excellent. Very nice. Santosh Nayak, welcome to the Gradeup dear. Welcome to the Gradeup. Ganesh dear, this is the welding process. Seam welding you are talking about. It is nothing but the continuous spot welding process. And in generally resistance welding, we are not going to apply any kind of additional material into the joint. Seam welding is the continuous spot welding process here. It is a spot welding process. It is a resistance welding process. Okay. Except see, the options are very hopeless. You can see spot welding, projection welding and seam welding. These are all resistance welding categories. Okay. Saran Kumar, good evening dear. Come on, join the session. Ask your friends to join the session. This will be the super Sunday for we. Okay. I hope Saran abhi utte. So gas welding, yes. Whenever in the gas, please again remember that there is no need of any filler rod material above 5 mm thickness of the plate. So whenever the gas welding is done for the plates less than 5 mm thickness, this is, you know, it is known as a puddling process. Puddling, it is called as puddling. But more than 5 mm thickness, you need to have the additional supply of the molten material, right? Then it is, we are calling it is a gas welding. I hope it is clear. Rahul, it is excellent. All are resistance welding, spot welding, it is a resistance welding. Projection welding is a multi-spot welding. Projection welding is when you are want to join one projected sheet to the flat surface. It is known as the projection welding. Okay, say this is a flat surface and you want to join here the sheet like this. Okay, so this is simply by having the two spot multi-spot resistance welding is nothing but the projection welding. Very good, excellent. All are correct. Yes, come on, tell me the answer. So solder is essentially, so Ganesh, friction welding, you can call it as it is solid state welding process. You can have the friction welding if the power consumption is low. You can use the friction welding on our day-to-day lathe machine also. So one part is rotating and we are forcing the other part onto the surface of this rotating shaft. Generally if it is circular one, that is very nice. So what happened? when you are applying the pressure with the other joining shaft onto the rotating shaft, then there will be the, because of the friction, there will be the heat creation, and all together when it is attached or get attached to this, get welded to this, they all together will rotate as a single body. So that is a friction welding. Okay, friction welding is a solid state welding process where you need not to clean the surface. You need not to clean the surface, as the during the first stage of this process, because of say plastic deformation, whatever the contamination layer or the corrosion layer is there, it is get out and pure material only get adhere or welded at higher temperature because of the friction between the two plates. So that is known as the friction welding. I hope Ganesh it is okay, and all the guys it is okay. Friction welding, solid state welding process, very good. So lead and tin, that is very this is a classical solder, dear student. Classical solder. If you see the lead and tin, the very famous eutectic diagram you are having, eutectic, you can have this diagram here, lead and tin. Okay, so here you are having the eutectic point. This is a classical solder, lead and tin. Excellent, very nice. Okay, Ganesh, I hope it is clear to you. You are not responding me. Very good. Thermit welding. Next question. Thermit welding, aluminum and iron oxide. Answer me the question. So you know the reaction. 8 aluminum ले लो plus 3 iron oxide ले लो. It will give 9Fe plus 4Al2O3 plus 2.1 megajoule of heat at around 3000 degrees centigrade. Exothermic reaction, where there is a 1 part of aluminum and 3 parts of ferrous. Very nice. Very good. बहुत बढ़िया, मजा आ रहा है भाई, बढ़िया लोग आए आज. Javed, very good. Yes, Boina, yes, correct. Shivani correct, Satish correct, Giriraj correct, Krishnamurthy correct. Yes, all are correct. So no one has given the wrong answer till now. Sobna Devi, it is correct. Very good, dear students, very good. So I hope the reaction is clear to you. So joining of the rails. Okay, So they say, see Kishore, from the reaction also you can able to see. Okay. So see that is the mixture composition of that thermit mixture is taken as, if you are having the 1 kg of this aluminum oxide powder, they are taking 3 kgs of iron, and it is a reaction. Generally the magnesium foils are taken as the catalyzers. Yes, 8 aluminum. So generally where you cannot able to have the electricity, say in the hilly area where the electricity it is not possible to have to run your transformers. Okay, so basically the rails, Indian rails, actually or anywhere go, the rails are generally get joined in the hilly areas, the jungles, roads. Okay, so where the route is going through the area where the electricity is not possible, where you are using this thermit welding. Then the ruler frames also can be joined with the help of the thermit welding. Okay, there is an exothermic reaction. In terms of weight, Kishore, I mean saying in terms of weight, it is not reaction, it is a weight generally taken. Okay, 1 gram as to 3 gram, 1 gram of aluminum powder as to 3 gram of iron. That is a mixture. That is correct. Yes. Next question. Spot welding is most suitable for joining the parts having the thickness up to, yes, up to what thickness? Up to what thickness? Please tell me the answer. The spot welding is most suitable for joining the parts having the thickness up to. Yes, correct. Boina, correct. Akhilesh Kharse, please check your answer. Ganesh, correct, Ganesh. Giriraj, oh my god, 30 millimeter. 30 millimeter means 3 centimeter. You just check. This is the spot welding. Yes, come on, answer me. Parneet, welcome dear. Sarthi, it is correct. Yes, Neha, Arora, it is correct. Giriraj, yes, Giriraj. 10 millimeter. Generally, we are, see, in spot welding, if you, in colleges also, we are having the project in the first year. Making of the tray or something made up of the plate or the sheets, okay. So maximum here 10 mm is more than enough. So D is correct. Dhirendra Kumar, correct, Dhirendra. So 10 millimeter. See, spot welding more than, to have the thickness of 1.5 millimeter, the current requirement in the spot welding is around 10,000 ampere. Okay, for 1.5 millimeter steel sheet, if I take up to 10,000. Thank you, Ganesh. So see, spot welding maximum 10 millimeter. That is correct. That is excellent. Next question. Thermit welding. Oh, once again. So within no time answer this question. I don't want to spend time on this. Come on. Yes, Bohina Rao. Yes, come on. So that is the very first, I hope, the shop floor experience for we peoples as a first year engineer students. So where we try to have some carpentry jobs, some smithy job to do, some welding jobs, right? Yes, exothermic reaction only. The exothermic reaction, it is giving you about 3000 degrees centigrade temperature. Yes, D for Delhi भाई, आज इंडिया जीता है, बहुत बढ़िया से जीता है. Okay, D Delhi is correct. Yes, making stool and all, making some rod, making some bend rod, some electric switchboard, right? All these things in the first year. That is yes, correct. Tell me, I hope no, without any hesitation, D is the correct answer. Without any hesitation, D is the correct answer. Next question. Spot welding, projection welding, seam welding. I already told you this question. Spot welding, seam welding, projection welding. Spot welding, that is the main resistance welding we can take. Projection welding is nothing but joining the projection part to the flat surface. Seam welding is nothing but the continuous spot welding. सीम को क्या बोलते हैं? सीम वेल्डिंग इज व्हाट? continuous spot welding, that is known as the seam. If you know the ball is having the seam, okay, if you are playing cricket, you know. Yes. Electric resistance welding. Resistance welding, tell me, AC current is used or DC current is used? AC or DC? AC or DC? So definitely here the tremendous amount of current we are passing through the plates. Say I told you for 1.5 millimeter of steel thickness plate, you can go up to the 10,000. More than that also you can go, but it is generally standard value we are having. So this much amperage, it is huge. So for that reason here actually we are using the alternating current. So very short period of time, in the fraction of seconds, the current is flowing through the circuit, and you know the heat generated in this resistance welding is given by R square R tau, where tau is what? The time for which the current is flowing through the circuit. Yes, leak proof joint in the pressure vessels, that is Shivani, absolutely correct. Yes, no money if you are using the DC, ये प्लेट पूरी जल के खाक हो जाएगी भाई. Javed, excellent Javed, excellent. If you use the direct current for that, the entire setup along with your plate, the electrodes all will melt. Money. AC welding we are using. T. Kishore, Arjun, what you are saying? So only for the fraction of seconds the current is flowing through the circuit. Please remember this. Please remember this, not DC. Next question. Tau means time. Tau means time. I told you, the reason I told you why it is so. Okay. So, please make your knowledge correct. Mani and Kishore, excellent. Very good. Electrode used in the TIG welding. So my God, this is the competitive exam question. Excellent. B Bombay is correct. B Bombay is correct. Yes, Shivani. Excellent, Shivani. Very nice. Very good. Next. In arc welding, temperature generated is of the order of in arc welding. Shobana Devi, correct. Yes, Rahul. Nice observation. But that thing also some people are not knowing. That is the difference, dear. So in the arc welding, dear students, generally normal sense, if you see, the temperature around 6,000 degrees centigrade is generated. Not like that. It is around 6,000 degrees centigrade. Yes, Sarthi, that is correct. In arc welding, dear students, the maximum temperature that can be generated up to 6,000 degrees centigrade. Okay, please remember, up to 6,000 degrees centigrade. That is correct. D is correct. Not even 7,000, up to 6,000 degrees, that is correct. Around 6,000 degrees maximum temperature is getting generated at the arc. So D is the correct. Okay. Yes, 6,000, up to 6,000, that is correct. So what is here nearest answer? I hope this is 5500 degrees centigrade. Okay. Yes, 5500 degrees centigrade. Okay. Black color is generally painted on. Black color. So this is a mixing chamber. This is C2H2. This is oxygen. This is right-handed thread wall. This is left-handed thread wall. This is the converging nozzle. Where the pressure energy is converted into the kinetic energy, and at the end of this nozzle, if you provide some burning initiation, the long and continuous flame is getting generated. Beta, khadse, the red and maroon, the red or maroon color is given to the acetylene. The red or red or maroon color is given to the acetylene cylinder, whereas the oxygen cylinder is painted with the black color. Yes, Mani, that is excellent, Mani. Acetylene is red, which is having the minimal. This is small cylinder of the acetylene. Oxygen is having the big cylinder, black color. Okay. Okay, so this is the right-handed thread, this is the left-handed thread. Can anybody tell me why the threads are different? This is having the maximum pressure withstanding capacity around 120 kgs per centimeter square. Red is acetylene. Okay, Giriraj has answered the question. Very good, Giriraj. No, twice. This is the Pokayoke, dear student. This is the Pokayoke. So this is called as, this is the Japanese term Pokayoke. Why? That is means error proofing. So इवन आपसे गलती से भी गलती ना हो, सो आपने हरी में या कोई गड़बड़ी में ये यहाँ का वॉल यहाँ पे लगा दिया और यहाँ का वॉल यहाँ पे लगा दिया. So definitely, dear student, the hose pipes which cannot able to, because the hose pipes also different. Oxygen is having is tremendous pressure than the acetylene, so there may be chances of failure of the hose pipe. So something get wrong. So error proofing, to foolproof the error. So the term called as Pokayoke is there. Pokayoke. Okay, so गलती से भी गलती ना हो जाए इसके लिए, right? So this is kind of Pokayoke. Okay, if you go into the industry, if you work in the industry, definitely you will come to know this word, that is the Pokayoke. Okay, very nice, Krishnamurti, very nice. Yes, safety purpose, safety, yes. So there are lot many terms we are using in the Japanese terms. Say Kanban is there. Okay, this Pokayoke is there. The 5 S's are there. Muda, Muri. Okay, all the terms generally used in the industries. Then Kaizen means continuous improvement. All the things we are using. Next thing. Magnetic arc blow eats. So dear students, this magnetic arc blow, definitely this is nothing but yes, Sunita, that the Kaizen means the continuous improvement. When you work in the industry, you want to improve your workplace in order of anything, in order of say cleanliness, in order of productivity, in order of say anything, then definitely there should be the continuous improvement you should do. So whatever you are doing, you should change something to get to the next level. That is meaning of Kaizen. So all of you know that the magnetic arc flow is nothing but the deflection of the arc because of the magnetic field which is generated because of the flow of current into the conductor. And this is more predominant phenomena, dear students, when we talk about the DC arc welding. Okay. So see, magnetic arc flow, that is simply occurring into the DC arc. So the one way to eliminate or you want to reduce it to go, you can switch from DC to AC. That is first thing you can do. You can make the arc shorter, that is the second thing can do. Then you can have the, for the main joining plate you can add some joining, other some part of some plate like this you can join to the other, if these are your plates, so you can add here the block, okay, so that, because see this magnetic current definitely in air it is not going to have to pass, because it is passing through the metal only. So like this, some things we can do to minimize this magnetic arc, okay. So definitely some remedies that are available you can use to minimize this magnetic arc flow, because of that what spatter is generating, and this is the kind of defect that you have, okay. I hope it is correct. Also the thing is that you can also reduce the current. If you reduce the current, the strength of this magnetic arc flow can be get minimized. That is also one thing you can do. So Ganesh, you are saying that 40 times thickness, this is the funda of seam welding. In seam welding, if you want to minimize the shunting of electricity, what you are doing, so up to 40 times thickness of the plate, you go on increasing the current condition. Suppose you want 10,000 ampere for the resistance spot welding. So for these two plates, if you are doing the seam welding, so you are slightly increasing the current conditions, not from the beginning, but unless the weld or seam length goes up to the 40 times thickness, you are providing the current in increasing order. So I was thinking what you are talking, actually you are talking about the seam welding, okay, seam welding 40 times thickness. So that is to avoid the shunting of electricity, that is correct, shunting of electricity can be avoided. Very good, so D is the correct option. Yes, next question, preheating is essential in welding. Preheating. So more than 1600 degree temperature, if you want to melt such a material, so definitely with the welding a lot of heat you have to gather. Yes, cast iron. So this can be the interview question, dear students, many times. So whether the first thing is whether the cast iron can be welded, so you should say yes, dear sir, cast iron can be welded, provided that the preheating should be there. Yes, very nice. So cast iron, that is correct, cast iron. Very good. Next question. The strain energy stored in the body due to the external loading within the elastic limit. So you know within the elastic limit the strain energy stored, which is the per unit volume within the elastic limit, and up to the point of fracture, these are two different stories, isn't it? So here the energy stored per unit volume, actually this is the modulus of toughness or toughness, that you know, modulus or toughness, or you can say the toughness. But up to elastic limit, the energy, strain energy which is stored, which is known as the resilience. So once again, D Delhi Jindabad. So Sri Kumar, why we are preheating? The preheating is basically done to minimize the gap between the room temperature at the temperature at which you are welding that particular part and its melting point temperature. If there is a huge temperature, so you require a lot of energy, okay, a lot of heat to melt the temperature from room temperature to that melting temperature. So what you are doing, we are certainly trying to decrease that gap, that is gap from T melting minus T ambient. So if you are increasing this, definitely at earlier you can able to melt the plate. And also there are so many reasons of the preheating, so that you can have the cleaning of the weld, you can have the evaporation of the, say, any water particles on the plate, any oil particles on the plate, say any grease is there, so it can be get evaporated. That is also the thing. Yes, that is to avoid the cracking. That is the preheating. Yes. Yes, all these things, all these things. Shivani, excellent Shivani. But in the case of cast iron, this is the basic thing. And the same way we can able to adjust the torch angle in case of the gas welding. Torch angle in case of the gas welding. Torch angle in the beginning we are keeping it at maximum, that is up to 90 degree. Because we want to heat the material from room temperature to its melting temperature. So that is one thing again. So to minimize that gap, we are providing the maximum energy at the beginning. Okay, maximum torch angle जो use करते हैं हम, generally it is up to 90 degree at the beginning and as minimum as possible at the end, because we don't want to spatter our molten material out of the mold pool, or sorry, well pool. Okay, so the thing is same only, we trying to minimize this gap, and the metallurgical things are also we can able to achieve, say the preheating to minimize the, or to reduce the thermal stress and all these are also possible. That is correct. So resilience, I hope this is the correct answer. Next question, proof resilience. I already told you these are the strain energy stores per unit volume. That is the modulus of toughness or modulus of this resilience, sigma square divided by 2e, that you know into volume. Are हाँ या ना? So Boina, are you from the Hindi medium, dear Rahul? It is per unit volume, per unit volume, per unit volume. Salim, I hope this is the first time you are attempting the question. Yes, per unit volume, per unit volume. And when we are talking or writing this is per unit volume, this is nothing but the modulus of resilience, or you can say for toughness. Also, if you are writing like this, so say for example, if I take the example of toughness, so this is the energy absorbed up to the fracture point. That is if you take the area like this is the area under this, nothing but what? Your energy up to the fracture. So that will be the sigma into the strain, that will be Newton per, say, mm square, into strain is what? Stress is Newton per mm square and strain is what? Mm per mm, mm per mm. So isn't it? So Newton, or if I write in terms of meter, Newton meter divided by meter cube. So Newton meter, nothing but the energy absorbed per unit volume, joules per mm. Okay. Okay, Rahul, very good, very good, very good. So it is per unit of volume, per unit of volume. That is correct, 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 correct. Very good. Okay, alloy containing the 36% nickel and 64% of the iron, that is known as very well known alloy. This is alloy of nickel, invar, ilinvar, then nichrome. These are the all the nickel based alloys, which are, if you know, you might have learned this invar in case of the casting chapter, casting technology, where it is having the coefficient of thermal expansion like 0.000096 microns per meter per degree centigrade. So the pattern allowance that you are providing here, yes, invar is there. Yes, that is correct. Very good thermal stability, very good thermal stability it is having. So even with the higher temperature it is not going to expand. That is the speciality of this invar. Very good dear students. Kapil Negi, very good. S is what? Array dear, SS is stainless steel. It is simply the nickel chromium. Nickel is there, chromium is there, not up to 36% nickel. Okay. If you take the example of the martensitic stainless steel, it is the nickel having up to the 8% nickel. If you take the austenitic stainless steel, it is having up to 2.5 to 8% of nickel. So 36% nickel is huge. Yes, money, that is correct. Zero coefficient of thermal expansion. Boina modulus of resilience per whole volume. Yes, yes, yes. Per unit of volume. Yes, yes, yes. Area into length of that specimen. Yes, yes, that is correct. Area into length. Cross sectional area into the whole length of that product or that test specimen. Take the next. The atomic packing factor. It is not factor, it is factor. The atomic packing factor is the highest in which of the following cubic lattice system? Tell me, come on fast भाई, maximum question और cover करने मेरे को. Raghunath, atomic packing factor, if you talk about simple cubic, where is rest? 52% I hope, BCC 68%, you know, FCC 74%, diamond 32 or 34%, that is the, yes. So out of that you can have the atomic packing factor. Okay, or how much void is there? 26% voids are there. Subramanian, very good. So C, face centered cubic and HCP, they are both having 74% of atomic packing factor. That is correct. It is 34. Okay, this is 34. That is correct. Anurag, very good. Next question. So see, already I told you just a moment before that with this question. Steel containing 18% of chromium up to 8% of nickel, it is known as, and it is, if you add here the carbon also from point, it is low carbon steel is there. Stainless steel में percentage of carbon बहुत कम होता है, 0.08% to 1.2% of carbon. This is known as the martensitic stainless steel. Okay, if you go for the chromium from 11 to 32%, okay, then it is known as the ferritic steel, stainless steel. And austenitic also I already told you, from 15 to 26% of the chromium. And nickel I told you how much, 2.5 to 8% of nickel, and carbon 0.02 to 0.15% carbon. So this is the austenitic stainless steel. Yes, A is the correct answer. A is the correct answer. Very good, Shivani, Salim, Anurag. Anurag, it is martensitic. Please check, it is martensitic. Yes, martensitic is correct. Then steel with the low, with the carbon below 0.8%. So I will just take a part of the eutectoid reaction. So this is your gamma austenite, this is the alpha ferrite, alpha plus gamma austenite, this is gamma plus Fe3C, and here you are having the thumb impression like structure, you know this is very well. This is 0.8% of carbon, you know very well. That is the 100% perlite is there, 100% perlite, layer by layer structure of ferrite and cementite. This is known as the Pearlite, pearl like structure. Pearl means like मोती की तरह चमकने वाला pearl, and light means having a very small structure. Light means very small structure. Pearlite, pearlite. So below that there will be the hypoeutectoid, hypo, and of course this is the eutectoid point, dear students, and moreover up to 2.1% of carbon, 0.8 to 2.1, it will be hyper, and of course base is what? Eutectoid. B Bombay is the correct. B Bombay is the correct. Very good. So again from the same, dear students, the hardness increases with the percentage in carbon content if you go on increasing. So definitely if you see here, like up to 6.6% ferrite and cementite is there, isn't it? Martensite is the phase because of the rapid cooling of the austenite. Pearlite is not so hard, yes, but cementite is very hard and brittle phase. So cementite, C cementite, that is correct. C cementite, C cementite. This is up to 6.67. This is lead boride, Fe3C plus gamma austenite. This is alpha plus Fe3C. This is the pearlite. Okay. This is delta. Okay. This is delta plus liquid. It's going to give you gamma. That is nothing but peritectic reaction. This is the hopeless reaction because occurred at very high temperature. No use. Only in the case of stainless steel we can consider more or less about that reaction. But very importantly, this is the eutectoid reaction and this is the eutectic reaction. Yes, cementite is correct. Cementite, C, Chennai, Chennai, Chennai. Chennai is correct. Chennai is correct. Very good, Rahul. Raghunath, very good. Then Kishore, very good. I hope Kishore you were there in the morning session 9 am. Kishore, morning session में थे आप? Additive manufacturing में. So dear student, do follow me on the Gradeup app. Do follow me on the Gradeup app. Martensite is the hardest structure, dear students. It is hard and brittle. Hardness of steel we are talking about. Martensite is a phase. Next question. So Ericsson test is concerned with Ericsson test is concerned with. So that is actually the Ericsson and Olson test. Ericsson and Olson test, where the sheet is placed on the circular blank and we are applying the load of 1000 kg from the ball. Okay, this is a ball, steel ball of the load of 1000 kg. In the stretching of the sheet. Okay, and we are applying the load till the your sheet is getting fractured or get failed. Okay, with the hard ball we are applying, and up to what depth the ball is indented over that sheet, the distance d, which is in millimeter, is known as Ericsson number. Yes, it is a cupping test. It is related to the cupping test. Okay, cupping test. Again, there are the tests which are used in the drawing operation, the known as the Swift and Fukui test. Swift and Fukui. So these are the drawings tests we are having, and these are the Ericsson and the Olson. These are the stretching test. Stretching. So to measure the ductility or the formability of the material. I hope it is clear. Ericsson or Olson, this is the stretching test to carry out, to check out the ductility of the material, and the Swift and Fukui test are the drawing tests. I hope it is clear. अरे भैया, अरे आ रहा है कि नहीं समझ में? सलीम, Arjun, Gaurav, very nice, very nice. C correct. Tell me the answer for this question. The Charpy test is conducted to measure Charpy test. Yes. Excellent. Very good. Very good. Very good. Very good. Very good. See, Charpy and ISOD, these are the tests which are used to conduct to check the toughness of the material. Yes, yes, Charpy and ISOD. Yes, yes, toughness is correct. Good, good, good. Next question. The materials having same elastic properties in all direction. Yes, Rahul, correct. The materials having same elastic properties in all the directions. That is at a point in all the directions. Say at a point in all the directions the properties are same. And at a point in all the directions the properties are different. Yes, this is isotropic. This is the isotropic. Very good, very good, very good. Very nice. Because of you, Rahul, I am also getting few of the Hindi technical words. Thank you, Rahul. Very good. C is correct. Gaurav, Shazab, Sarthi, Salim, Mani, Gaurav, Javed, all are correct. C is the correct. An optical flat measures the flatness of the surface by using the principle of MH, Maharashtra. Dharmik, who is she? Oh, very good. Yes, it is the optical flat. You know, it is flatness measuring. Generally, yes, optical flat. Also, we are measuring the flatness of the gauge blocks by the optical flat. Yes, interference. Yes. Thank you, Dharmik. Yes, interference is correct. So let's move faster. Oh, excellent word, Rahul. Excellent word. So you know that interference is nothing but in case of the wave theory of light, it is nothing but the phenomenon of enhancement and the cancellation of the wave due to the superimposition of the waves. Right? That is the interference. Wave theory of light. The Huygens principle were there. Every point on the wavefronts acts as a source of secondary light by sending out secondary wavelets in all directions. The envelope of all these waves at any later instant gives the new wavefront at that instant. I hope this is known to you. Hygiene's principle for wave theory of light. Optical, I already do gauge blocks. I already told you just now the gauge blocks also, the flatness of that, it is checked by using the optical flat. I already told you before. Then it's fine, Kiran. So this kind of question only you are going to get. Practice it. D is the correct answer. This is known to you. I hope these questions are known to you. I am going to wind up. Tell me this answer for this very simple question. So numerical question, I have to plan some different sessions. See, strategy is when you are have the strategy, when you are having the enough preparation. Okay, I hope you all will be having the enough preparations. So at this moment, only the thing is that maximum from anywhere you are getting the practice sessions, you please attend the sessions, practice the things, just brush up the things. Okay, I can do that, Kiran, but definitely they, after 1 week we are going to plan for that. So proper with the numericals, I am also very interested in that. But the format of the question papers is somewhat in this fashion, so we are conducting the questions like this. And of course, these are the asked questions in the previous competitive examinations, and that can boost up your, of course, the confidence. Right? Yes, this was the last session from my side, from as far as the production engineering is concerned. I hope it is helped you for boosting of your confidence level. Tomorrow maybe the machine design is there. Let us see what is there. But as far as my knowledge is based, this is my last session I am having here. So Kiran, just go through the practice. At this stage, this is not time to read something new or to have some conceptual things in your mind at this particular time. Whatever you have the knowledge with that, just try to brush up the things with the questions. This series is already running, no? Materials science also we try to cover some portion or some parts, some questions on that. If I get any additional session, definitely I will go with the material science in depth and in industrial engineering. I hope for you people only we are here. So that is, thank you Sarthi, Shivani. If we plan, definitely I will conduct the same session. If industrial will be there, definitely I will conduct that. Let us see. But I hope this is all well planned, this series for you guys. We are trying to cover each and every subject. So dear students, do follow me on the Gradeup app. Don't forget this and like this session. Share this session among your friends. Okay, and you see here, these are the courses launched by the Gradeup Super. That is the Gear Up App Rank Up 2021 for this 2021 examination, GATE examination, dear students. And if you see this Vision 2022, if you are the students from second or third year, dear students, please you go through these details. No anywhere else you will get this kind of course. Okay, this Vision 2022 for ESE and GATE 2022. It is very ideal course for the people, for the students who are at this moment, who are in the second or third year. For any details, you just contact on this number. For your any doubt, any queries are there, definitely get resolved. These are our star faculties from the Gradeup. Okay, these are well-known faculties across the country, dear students. These are our achievers in top 60, the top 100, the 60 candidates from the Gradeup. And dear students, thank you so much. Thank you so much for joining the session. Definitely, after 10 days, again, we are going to start something new for you people only. At that time, do join the sessions. Thank you so much, and all the best, all the very best from my side for your examinations, your preparations. May God bless you all. Thank you so much. Bye bye, and Jai Hind.